You can understand digital logic without having to understand electronics, but I do like to start out by showing you how transistors work so you get an idea of why we consider Boolean logic, zeros and ones, as being in circuit, high and low, or on or off, depending on which way you prefer to look at it. So to start, we're going to go out to falstad.com. That's www.falstad.com. And it doesn't look like much from here, but we're going to pick on the circuit simulator. And this circuit simulator is really nice because you can see the components, you can see graphically the current flowing, either red or green here. You can see all the components. You can actually play with them as they're operating. Okay. And you can see what's going on in instrumentation. If you care to add that, you can play with the values in your circuit. It's actually a cool simulator, but unless you're really into electronics, this is not what I'm here to show you. What I'm here to show you is they have a bunch of circuit examples, and we're going to roll down here to transistors. There it is. NPN transistors will start. Okay. And we get a simple little circuit of a transistor. And you can see that basically we have this small voltage and a relatively small current going into the base of the transistor, and it's controlling the flow across this transistor. And so if I play with that base voltage, for instance, if I go to here, you can see suddenly the current is very much. And if I go the other way, it gets relatively less. Okay, and so this is actually using a small amount of current to modulate a larger current. This is amplification. You could use a small current, say the signal from a microphone, to modulate the large current to a speaker. And again, you have amplification. It's more complicated than that, but this is not what we're using it for. So let me pull up my version of this file, NPN transistor. Okay, and what I've done is I've added a switch here. So my circuit is basically either there's input here or there isn't input here. And if there's no input here, there is very little current flowing through because a transistor isn't perfect. And so little current will leak through. And that's why we say high or low rather than on or off, because truly in a circuit like this, there is no off, but there is low. And so now I can turn it on and current flows through, turn it off, current stops, on, off, high, low. Okay, that's the idea. And that's how we use this. By the way, this is pretty much the way that vacuum tubes used to work for vacuum tube computers. And this is also pretty much the way a mechanical solenoid works. The difference being that a mechanical solenoid, when you turn on the power here, it actually pulls a magnet to close the circuit. And closing that circuit allows greater power to go through. So when you're running a starter, it's just a little bit of power that closes that circuit that allows a whole lot of power from the battery to go to the starter. And that way you don't hurt yourself by trying to close a switch on a large power source. Right. That's just a little bit of side knowledge. Now there's another version of the transistor, which is the PNP transistor. And its circuit looks pretty much the same. So the big difference is instead of a ground, we've got a 0 voltage here. Okay. And we are running a slightly higher input voltage, but it works the same basic way. Okay. So that the more that voltage goes up, the more current flows through. Okay. Actually, it's just the reverse. The less voltage there is, the more current goes through. But I can hook it up the same kind of way. Open file, open my PNP transistor. Okay, and now with it open, nothing flows through, and with it closed, something flows through. So from that point of view, it looks exactly the same, even though the input is usually inverted. It's when you have that absolute zero. However, it does make a difference when we're not using zero, but actually low as an input. So as you saw before, a low input actually increases the voltage going through. So it's a reverse sensing transistor, if you will. Okay, that's enough about transistors for this point. So now we kind of understand why circuits have low or high, which we interpret as on or off, or 0 or 1. Okay? And so with the next video, we will look at counting systems using 0 and 1, in other words, binary, and how to convert from other systems. And then we will, from there, move on to actual digital logic circuits. And we'll show some of the base circuits in this form in Falstad, so you can see how they actually work, how the basic components work. But we'll build our more complex circuits in another tool that I'll introduce later on. Okay, I hope you enjoyed this. See you soon.